So number 15 is asking us to find all solutions of the equation in the interval 0 to 2 pi of this equation here. So we got two different trig functions here. So what we're going to do is set each of these in the parentheses equal to 0. So we're going to do cosecant of x minus 1 equals 0, and then we're going to do secant x minus 1/2 equals 0. So we'll attack the first one here, cosecant x minus 1. We'll add 1 to both sides, and that'll give us cosecant x equals 1. And then we know for our trig identities that cosecant x equals 1 over sine x. So we're going to substitute 1 over sine x in for cosecant x. 1 over sine x equals 1. So if we multiply both sides by sine x, alright, so those signs will cancel out, and we'll get 1 equals sine x, or sine x equals 1. So how do we figure out what angle, sine of what angle is equal to 1? Well, there's two different ways to do that, at least two different ways. First way is to draw the unit circle. Yep, my circle's really ugly. So anyways, so this point here is 1, 0, and this point here is 0, 1. This point here is -1, 0, and this point here is 0, -1. Alright, so for each one of these points, the x value represents cosine, the y value represents sine. So this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360. Alright, so then we're just looking for which angle. We have a 1 for the y coordinate. So here the y coordinate 0, that's not what we want. So here we have a 1 for the y coordinate. So the sine of 90 degrees, sine 90 degrees is equal to 1. Okay. Notice the y value of 180 degrees is 0, and then the y value of 270 degrees is -1. So anyways, the other way to figure out what angle, sine of what angle is 1, is to draw the actual graph of sine. So 90 degrees is equal to pi over 2. Notice, roughly speaking, because that the graph of sine here touches 1 at 90 degrees. So it's just another way. So if you, sorry, I'm running off the page. So sine of 90 degrees is 1 right here. So that's just further proof that sine of 90 degrees is 1. So there's two different ways: the unit circle, and then using just basic graphing out the sine function. So the solution for cosecant of x minus 1 is x equals pi over 2. Alright, now we go over here and we focus on secant x minus 1/2 equals 0. So we're going to add 1/2 to both sides. So that's secant x equals 1/2. Now our trig identities, secant x equals 1 over cosine x. Alright, so we're going to substitute 1 over cosine x in for secant x. 1 over cosine x equals 1/2. Alright, so if we multiply both sides by cosine x, that's going to give us 1 equals 1/2 cosine x. And then if we multiply both sides by 2, we're going to get 2 equals cosine x, or cosine x equals 2. Alright, so there's a problem with that though, and I'll explain what the problem is. So we just draw a right triangle and we give this angle over here x, right? So that would be understood to be 2 over 1, and cosine of x equals the adjacent leg, which is this, which would be 2, over the hypotenuse, which is 1. Well, if you do Pythagorean theorem on this and say that 2 is equal to b and 1 is equal to c, so it's a squared plus b squared equals c squared. This would be a. So it would be a squared plus 2 squared equals, 1 squared. And if we solve for a, so that's a squared equals 1 squared minus 2 squared. Take the square root of both. That gives a equals the square root of 1 minus 4. A equals square root of negative 3. But we can't have a dimension of a negative number over here. So basically what happens is secant x minus 1/2 equal 0 is undefined. And since so basically we have pi over 2 times undefined, the final answer is going to be undefined, because we're basically looking for a value of x that will render this thing equal to 0 at the same time, and we don't have that because we have an undefined on secant x minus 1/2. So the final answer for this problem is undefined.